Hello and welcome to SudoKanard. I found this puzzle called Unlucky by Lisztes or Mike November, and it was published on the Cracking the Critic fan server on Discord, and it's a regular Killer Sudoku, but with the unlucky theme being 13. So you see all killer cages are 13, and there's this one and this 3. So I'm going to attempt to solve this. Where should we begin? Well, let's have a look at those boxes, those 3x3 blocks. The total sum is 90. And we have a total of 78, so this plus this is 12. That's not very helpful. There are only 3 ways of making 13. Oh, that's 39, 42, so those are 1 and 2. That's something already. So 13 with 2 cells can only be 6 plus 7, or 5 plus 8, or 4 plus 9. 26, 30. So this is 15. So this one is this one plus 2. 26, 29. That's 17. Oh, 17. Oh, really? So 17 here. That's 30, 43, no, that's not possible. 26, 29, so that's 16, 16 plus 26, that's 42, so this is 1 and 2 again. And this includes a 3, obviously. Okay, and this one is different from those. Now, there must be a 3 somewhere in one of those cells. Oh, okay, so now this is 10, 23, 36, so this plus this is 9. Well, this 10 could be 3 plus 7 or 4 plus 6. No, 4 plus 6 is impossible because it would remove 2 of those possibilities for those cages. So it has to be 3 and 7. So those are those ones, 5, 8, and 4, 9. So the remaining digits must be 1 or 2 somewhere, and 6. Okay, and there's a 6 in one of those cells. So that's 26, that's 19. Not much that I can do with this. Where else can I look? So this is 19. 19 with 3 cells is somewhat restricted, but it can't contain a 1. 19 can't contain a 1 with 3 cells, so there's a 1 somewhere in those cells, and there's a 1 somewhere in those, but not in here. So 1 here or there. A 1 somewhere in those cells, but 1 and 3 actually are in those cells. They could be both in the 13 cage together with a 9, but one of them could be here. So that's not helping me. Let's have a look at this. That's a total of 17 with 4 cells, only 2 possibilities for this 13 cage, 2, 4, and 7, or 2, 5, and 6. And each one of those remove 2 possibilities for this cage. The first one would make the cage 5 and 8. The second one would make the cage 4 and 9. So we know that 6 and 7 do not appear here because one of them is here and the other one is in one of those cells. And actually, so that's the content of this cage, and the missing digits then are 6, 9 in the first case and 7, 8 in second case. Yes, that's 15. Oh, I already mentioned that earlier. And this is 2 more than this one. Where else can we look? Can we have something? We can have the sum of all those digits. I doubt that it would be really interesting. But we know something about this. We say 26, 29, that's 16. So this plus this is this plus 3. So this digit must be in one of those cells. And that's only obvious if you consider this row, 13 combinations. The third one must be here. So that's nothing really new. Oh, what else can we find? That's confusing. That's I'm not sure what I'm supposed to find. So there's a 2 in here. With the 2 in here, we have a 2 in one of those cells. It can't be here. And we know there's a 1 in one of those cells. And we can't have 1 and 2 both in this cage because the third digit would have to be 10. We could have both here, I think. Can we? It would make this 16, 29, so those would add up to 16, which would work with 7 and 9 in some order. Well, seven and 9. Actually, I don't think, I'm not sure no, it wouldn't work. If we put 7 and 9, so that's under the assumption that we have the 2 here and the 1 there. Then we have 7 and 9, that's a 4, meaning that would be a 6, meaning that 6 and 7 don't appear in those cells, nor in this cell, and there's only 1 cell remaining. That would not work. So 1 and 2, one of them has to be in one of those cells, and the other digit must be in one of those cells. That's not much, but that's something. Actually, the pair that appears in this cage can't be in either of those cages, so it must be here. So they must be here. They must be in those cells. So 3 is here actually, and so this digit is the same as this one and this one. Those digits add up to 13. So that's 39, and those cells add up to 6. So they couldn't be 2 and 1, really. So it's either 2 here and 4 there, or 1 here and 5 there. That's sort of funny, I think, I guess. So now, in each case, this digit must have its counterpart. The non-1, 2 digit here must have its counterpart in this 3-cell cage. So we have one 13 pair here, the other one here, and the other one across the non-cage cells and this 13 cage. So for example, 2, 4 here, and 1, 9, and 3 here. And 3 must be in one of those cells. So it will either be 2, 4, and say 1, 3, 9, or 5, 1, and 2, 3, 8. One of those. Okay. And the missing digit could be anywhere. I think. There's a 2 here. Yes, well, already mentioned that. Now, what more can we find? Not sure. Well, I see that someone else attempted this puzzle and gave up. I hope I'll be more perseverant. I guess this exists in English. That's a French word, to be sure. So what about this row? We already have 26, 30, so that's 15 for the remaining 3 cells. But there are several possibilities. There has to be a 2 in no, it could it be 4, 5, 6? No, 4, 5, 6 wouldn't work. There has to be a 2, obviously. 2 is not in those cells. But that doesn't help me. 2 could be here or there, could be here. How am I supposed to make new progress? There's a 6 in one of those cells. It's not here. It's not here either. Could be here or there. And the sum is 19. That's it. So the remaining 2 digits must add up to 13. So has that result? So if I put a 6 here, the other digits must add up to 13. So this is the same as this one. Okay. But is this possible? Let's say this is 4, 9, so it has to be 9. But now this should be 5, 8. should be 5, 8. So those would be 6 and 7. 4, 9, 4. It seems to work actually. 7, 4, 8. No, it seems to work. I thought there would be some incompatibility. And is there any issue with putting a 6 here? Let's say that's 4, 9. Then it has to be 4, 9 the other way around. And it would definitely have an issue with uniqueness, but that's not the proof that it doesn't work. Now it would be 4, 8 here. It would be 4, 9 here. 6, 7 here. And still no reason for it not to work. I think no reason for it not to work. But 5, 8 here. This is 39, so those must add up to 6. And without using 4 or 5, that's not possible. But that's assuming 4 and 9 in this order, actually. So I was assuming a bit too much, I think. That's too harsh. That's too much of a bifurcation, but I'm not sure it is. Actually, if I put a 6 here, then this is 13, then this is 13. And without using the 6, so 7 has to be here. And those must, without using the 6, so 5 and 4 are in there, and this can't add up, those digits can't add up to 6. So that's not possible. And that's good logic. So 6 has to go here. So this is a 7. And now what happens? 26. So those must add up to 13. So this digit is the same as this one. And this digit is somewhere in one of those cells. So this one is the same as this one. Should I highlight them? So I could say that this one is the same as this one, and this. So that this is not here and 7 is not here as well. So 6, 7 is here actually. The 6, 7 pair is here. That's it. That's correct. So this is either 5, 8 or 4, 9, and this is the other one. Let's say I make this blue. And what? 6, 7 has to be either here or there. But we saw that this couldn't be 6, 7 because of the because both decompositions of 13 use a 6 or a 7. So this is the blue one. And 6, 7 are in those cells. Okay, this is progress. Now this one can't be the same as this blue pair this one is not the same as this red pair. It has to be the blue pair. And we saw that this digit is the same as this one. And its counterpart must be found in those cells. But this is 7, that's 20, that's 33. Those add up to 12. Well, that's not sure about how to do this. This couldn't be red. It could be blue. It could be 7 here and 6 here. Oh. Well, not sure about what goes on. But here, where are 6 and 7? One of them is here, the other one is here. That's it. The other 6, 7 is not in those, it must be here. Let's say 7 and 6, and then synchronize those. That's 2 scenarios. The other one is here. Oh, let's synchronize them with this 4 or 1. If I manage to make sense of what I just said. If this is a 4, then this must be 2, 5, 6, making this a 7, making this 4, 9, and this 8. And 5 and 2. That seems to work. If I make this a 1, making this a 5, then this is 4, 9. It has to be 5, 8, and this has to be 2, 4, 7. Yes, that's it. So there is actually a 4. And making this a 1 puts a 7 here, making this a 6. So those are really consistent. Well, those are just 6 and 7 in any order. And that's it, I think, about this. Maybe I should dig deeper. Not sure about that. That's not 6, 7. It has to be either blue or red. This can't be blue because of this. It could be 6, 7. It could be the red option. That's just being Captain Obvious, I guess. 19 again here. What are the options for 19? 9, 8, 2. Yes. 9, 7, 5. No, sorry. 9, 7, 3. 9, 6, 4. 8, 7, 4, 8, 6, 5. And I think that's it. That's still 5 possibilities. But there's 9 or 8 here. And we could have 6, 7 here. In which case, this is 9, 8, and 2. We have 1 here anyway. We could have 1 and 2 in here, or we could have 2 in this cell. with 9 and 8 here. But no, it wouldn't work. 9. Oh, we could have a 2 here. We could have 2 here, 1 and 8 there, 9 and 8 there with. So nothing really useful. That's a difficult puzzle. Oh, I see that Mike suggested an addition to the rule set. So there's an additional rule because Mike found the puzzle to be a little hard. Quotation marks around little. So there's an addition, which is that the non-cage cells in column 1, non-cage cells should add up to 13, which is nice, actually. And which would force those to be 7 and 2, actually. I think I'll use the additional rule. I wonder what would work to solve it without using this. But so this is 7, that's a 2. So 1 is not here, that's a 4. Okay, so if making this a 4, we have 2, 5, and 6 in those cells. This is a 7, this is a 6. And now this, so the red option is 5 and 8. Okay, so that's 8, this is 5, this is 8, 5, 8. We'll see about those. This is 4 and 9 now, so that's a 4, that's a 9. 9 here, 1 and 3. 4 and 9 in these cells. Now this can't be 4 and 9, it can't be 8. Oh, I should have noticed that this had to be 6, 7. It couldn't be the same as this, nor the same as this. So it had to be 6 and 7. This is not a 6. So this is not 6, 7 either. It could still be 4 and 9, although that would raise an issue of uniqueness, I guess. Now that's 6, 7. Making this a 7, that's making this a 6, that's a 3, that's a 7. So those are the other two pairs. So this is not a 5. And now we have 2, 6, and 7 in those cells. So this is not 6, 7. That's not an 8. Could still be 5, 8, or 4 and 9 in some order. So we say that 4 and 9 go here. 2 options for 5 and 8. 4 and 9 go in those cells. Also, we know now that this is not 4 and 9. They have to be 5 and 8. So it's 5 here, 8 there. This must be 4 or 9. 5, 8 here. the other digit must be in those cells. 1, 2, and 3 must be somewhere around. 7's here. Let's have a look down there. The counterpart of this is in one of those cells. This plus this is 12. It could be 8, 1, and 3. It could be 5. Oh, none of them go with the 2. 2 here would have to repeat a digit. So 8, 1, and 3, or 5, 1, and 6. No, 6 is not available. 6, 5, 6, and 1. So this is either 3 or 1. And one of those is in this box. 8, 3, and 2. 5, 6, and 2. Yes, I think. What next? So this additional clue allows for progress, but it's still not shattering. Oh, this 5 gives a 2 here. That's a 6, that's a 5. No 6 in those. 6 has to be in one of those cells. And we need another 7 without using 2 or 5 or 6, so it must be 6, 4, and 3. So that's a 9, that's a 4. 3, 4, 6, that's a 1, making this a 1. This one's not 6. This digit must be 3 or 9. But 3 would need 1 and 3, 9 would need 1 and 3 here, which is not possible. So that's a 3, that's a 4. This is a 9, that's a 4. Okay. So 2 and 9 in those cells. Those now must be 2 and 9 as well. With this 2, that's 2 here, 9 here, 4, 8. Making this a 5, this an 8, this a 5. So now that this is a 5, we have an 8 here, so it has to be 8. 8 in this cell, together with 3 and 2. So this is a 2, that's a 1, that's a 6, that's a 3. It fixes this, and 9, that's a 4, that's a 7, that's a 2. Okay. In this column, let's have 2 in this cell. 1, 5, 6. That's 12. So this must be 1 less than this. So this 1 here will make this a 2. 5 here is not possible. So that's a 6. That's a 7. Together with 1 and 5. 9 here, 3 there. Making this a 1, this a 3, this a 5, this a 1, this a 7, this a 6. And now 1 here, 3 there. That's a 2, that's a 1, that's a 9, that's a 2. That's a 4, that's a 9. And let's finish all this with a 4. No. Yes, a 4, that's a 5. Yes, that's all right. Making this an 8. And this completes the solve once I've really removed all possibilities. So this wraps up the solve, and so I tried to solve it without using the additional clue, but I wonder how you can manage to solve it without using that. So this additional clue in the first column was very nice to, and the whole puzzle was nice actually. It was a really good logic with this 13 theme. So thanks, Mike. Thanks to Lisztes. Not sure about the pronunciation of this pseudonym. And thanks for watching this video, and see you pretty soon, I guess, I hope, on SudoKanard.